Hello, we are back. We are here on chapter 8, quadratic equations and functions, and we will work on section 8.1, solving quadratic equations by completing the square. The first objective is to use the square root property to solve quadratic equations. And we previously have used factoring to solve quadratic equations. This chapter will introduce additional methods for solving these quadratic equations, and let's have a look at the square root property. If b is a real number and a squared equals b, then we can say that a is going to be equals to positive or negative square root of b. Because if we square this, if we square the positive square root of b, you're going to have the result b. If you square negative square root of b, you're going to have the result b is going to be a squared, right? So this is the square root property that we're going to apply, we're going to use to solve a few examples. Let's say we have x squared equals 49. What are the numbers? What are the numbers that if we square, we're going to find 49? And the answer is x equals positive or negative square root of 49. Because square root of 49 is 7. We know square root of 49 is 7. So positive or negative 7. If we square positive 7, we're going to have 49. If we square negative 7, we're going to have 49. Solve 2x squared equals 4. And this, on this example, we just need first to divide both sides of the equation by 2, right? To simplify. And then we're going to have x squared equals 2. That means x equals positive or negative square root of 2. And this is going to be the answer. More examples, and we have a few more examples here. Now I have an expression, y minus 3 squared equals 4. This will result, if we apply the square root property, we're going to have y minus 3 equals positive or negative square root of 4. And then we're going to have two different answers here. We're going to have y minus 3 equals positive or negative square root of 4, 2. And let's first get the positive. Y minus 3 equals positive 2, right? That means y equals, add 3 on both sides, y equals 5. Or y minus 3 equals negative 2. That means add 3 on both sides, y equals 1. So this example here, we're going to have two solutions, two different values for y. As we can see here, y can be 1 or y can be 5. Another example, solve x plus 2 squared equals 25. And the same step by step, same method, x plus 2 equals positive or negative square root of 25, which is going to be positive or negative 5, right? So let's do the same thing. First we get the positive 5, x plus 2 equals positive 5. Subtract 2 on both sides of the equation, and you're going to have x equals 3, or x plus 2 equals negative 5. Then subtract 2 on both sides of the equation, x equals negative 7. That means x equals 3 or x equals negative 7 are the two solutions for this equation, for this problem. One more example, we have here one more example. 3x minus 17, the whole thing squared, equals 28, okay? So 3x minus 17 is going to be equals positive or negative square root of 28. But the square root of 28 is going to be, we can write as positive or negative square root of 4 times 7, right? And this is going to be equal to positive or negative. We can take this 4 here outside the radical, because 4 is 2 squared, positive or negative, 2 square root of 7. And that's, if we simplify, actually, let's write this here, 3x minus 17 equals positive or negative 2 square root of 7. What can we do? We can actually apply addition property and simplify. Let's add on both sides of the equation 17, and then we have, moving up, we have 3x equals 17 plus or minus 2 square root of 7, and we can divide both sides by 3. Let's divide by 3. Let's divide here by 3, and when we simplify, we get, let me just get this here, we get rid of this, we get rid of this 3, this coefficient 3 from x, and this is the solution. Actually, we will have x equals 17 plus or minus 2 square root of 7 over 3. And this is the last example for this objective. Now we have the objective number 2. Solve quadratic equations by completing the square. And the process of writing a quadratic equation so that one side is a perfect square trinomial is called completing the square. It involves creating a trinomial that is a perfect square, setting the factor trinomial equal to a constant, then using the square root property. The step-by-step of solving a quadratic equation in x by completing the square is: the first step, if the coefficient of x squared is 1, you go to step number 2. You can skip this step, otherwise you divide both sides of the equation by the coefficient. Number 2, isolate all variable terms in one side of the equation. Step number 3, complete the square for the resulting binomial by adding the square of half of the coefficient of the x to both sides of the equation. Step number 4, factor the resulting perfect square trinomial and write it as the square of a binomial. And number 5, step number 5, use the square root property to solve for x. And maybe you didn't understand just by reading this step by step. I wouldn't, but we will understand when we work out this example that we have here, right? So let's solve example 5 by completing the square. And just to remind what a complete square looks like, let's have a look here. We need to complete the square of y squared plus 6y equals negative 8. The first step, as stated here, the first step, we don't need to go through the first step because the coefficient is 1, right? The second step, isolate all variables and terms on one side of the equation. This is already done. All the variables are isolated on the left hand side. So we're going to go to the third step, complete the square for the resulting binomial. So let's complete the square. A complete square looks like this: a square plus 2ab plus b squared. This is a complete square, right? So we have here a square is y squared, so this is the a, And that term is going to be 2 times a times b. 2 times a times b. And that's how we're going to find the missing term, which is b or b squared. Let's find b. 2 times a times b is equals to 6y. We see that y is our a. That means 2 times 3 times y. Y is our a, right? Y is our a. And check it out. 2 times 3 times y. Can you see what's the term that's going to be b? Check. This one, right? We have 2. We have a is y. And b is going to be this term here. So to complete the square, we need to actually add on both sides of the equation 3 squared. This is what means completing the square. So let me just erase this thing here. We found out that the term that's missing here is going to be b squared, and b is going to be equals to 3, right? So y squared plus 6y plus b squared is 3 squared, 9, equals negative 8 plus 9. We added 9 on both sides of the equation. Now we can change, we can substitute this by the square, this equivalence here. This is equivalent to a plus b squared. And this is equivalent to y plus 3 what? Squared, right? Equals negative 8 plus 9, 1. At this point, we can actually solve by applying the square root property. We apply the square root here, the square root here, and the square root, and this is going to be positive or negative 1, right? Positive or negative. Positive or negative. This is the square root property. I'm moving just up a little bit. So we have square root of y plus 3 squared is y plus 3. And square root of 1 is 1. Positive or negative. Oops. Because square root of 1 is just 1. 1. We will have two solutions. Two different solutions. One is y equals y plus 3 equals positive 1. If y plus 3 equals positive 1, the solution is negative 2. Or y plus 3 equals negative 1. Then the solution is going to be negative 4. We have these two solutions that we could find using the method of completing the square. Let's have a look at another example. Another example here. We have y squared plus y minus 7 equals 0. The first step of our method, our step-by-step procedure is we don't need to apply, right? Because the coefficient here is 1. The coefficient is 1. So we don't need to apply the first step. The second step is to isolate all the variables in one side. So we will move the number, this number here, to the right hand side. Y squared, y squared plus y equals, add 7 on both sides, addition property, so we're going to have equals 7. Excellent, wonderful. We have y squared plus y equals 7. And remember, I'm going to write again so we don't forget that we are completing the square. So it's the complete square is a squared plus 2ab plus b squared. That means y is going to be our a. Let's write down here. Y squared is this first one, this first term. Y is the second term. So 2 times a times b equals y. Now we have to figure out what's going to be b. Let's write down here 2 times, this is our a, 2 times y, and we have to find b. To make this equal, what we need to do here, we need to multiply by 1 over 2, right? 1 over 2. That kind of means, that kind of shows us that to complete the square, we need this. We need to have b equals 1 over 2. Let's complete the square. Let's apply b equal 1 over 2. b equals 1 over 2 on our equation. And I will clear this up. We don't need this anymore. Let's apply this to our equation. Y squared plus y plus b squared. Now we need b squared. b is 1 over 2. b squared is going to be 1 over 4. Right? 1 over 4. And we have to add on both sides. 7 plus 1 over 4. We have to add on both sides. Because now we can rewrite this as the equivalence. A plus b squared. A is y plus b is 1 over 2 squared equals 7 plus 1 over 4. And 7 plus 1 over 4, we can actually put together and do the addition here. 7 times 4, 28 plus 1, 29 over 4. Okay. So 29 over 4, and apply, at this point you're going to apply the square root property. Let's apply the square root property here, and square root here, and this is going to be positive or negative. Okay, let's use this space here to complete. And we can rewrite, you can write here y equals, and subtract 1 over 2 from both sides of the equation, right? So you're going to have y only on the left hand side, and on the other side negative 1 over 2 plus or minus square root of 29 over, and square root of 4 is 2. The solution is going to be, they have the same denominator, y equals negative 1 plus or minus square root of 29 over 2. This is the final answer, the final solution for this equation here. Okay, and another example. Now we have another example, and now actually we have to apply, we have to use the first step, because the coefficient here is not 1. So let's use the first step, and we have to divide the whole equation, both sides of the equation, by 2. So dividing both sides by 2, we have x squared plus 7x minus 1 over 2 equals 0 divided by 2, 0. And now the next step, move everything, every variable to the left hand side, one of the sides, and everything else, so the numbers, to the other side of the equation. So that's what you're going to do. Let's keep just x squared plus 7x here, and by Applying addition property, we add 1 over 2 in both sides. So 0 plus 1 over 2, that's it. The next step is going to be to complete the square. And remember, the square, let's write in green. We have this is going to be A, this is going to be 2AB, and we are missing here what? B or B squared. X is A squared. This 7x is 2ab, and we're missing b squared. Okay, let's initially let's figure out what's going to be the value of b. 2ab equals 7x. Let's rewrite this with the 2 in front of it. 2 times 7 over 2 times x. Okay, so we have 2, we have a is x, and b is going to be equals to 7 over 2. b equals 7 over 2. And by finding it, we can complete the square. Let's complete. Up here, let's write, let's add b squared on both sides of the equation, okay? So x squared plus 7x plus b squared, 7 over 2 squared, b squared is going to be 49 over 4. So plus 49 over 4 on both sides equals 1 over 2 plus 49, 49 over 4. Oops. Okay, let me clean this up so we have more space. Let me clean this. We have more space here to work because we already found b. We already know what is the term that we need to complete the square. We complete it here, and we can rewrite this equation as the equivalent. A is x plus b is 7 over 2 squared equals what? 1 over 2 plus 49 over 4. 1 over 2 plus 49 over 4 is going to be, let's say this is 2, this is 4, so we can add 49 plus 2, 51, 51 over 4. Apply the square root property. So this is equals to square root of on both sides. And here, don't forget, here you're gonna have this equals to positive or negative. Okay, this is the square root property. We apply the square root on both sides, and here on the number you're gonna use positive or negative. And that means x plus 7 over 2 equals what? Positive or negative? Square root of 51 over 2. Okay? And we can use here, I can use, there's a space here with a different color. Maybe, let me see if you're going to be able to see. X. Let's subtract on both sides 7 over 2, applying here addition property to simplify and have only x on the left hand side. X equals negative 7 over 2 plus or minus square root of 51 over 2. Okay? That means x equals, and we can, they have the same denominator, right? Negative 7 plus or minus square root of 51. This is the final answer. This is the solution of this equation that we have solved by completing the square. Our next objective, number 3, is to use quadratic equations to solve problems. And let's go straight to an example. Use the formula A equals P times 1 plus R exponent t to find the interest rate. This is the formula of compound interest. You have the amount equals the principal times 1 plus rate over the time. If the interest rate, if $5,000, 5,000 is going to be the principal, is compounded annually and grows to 5,618 in 2 years. 5,618 is the amount A, this is P, and this is the time. First thing that we have to do is to understand the problem. Since 5,000 is compounded annually, we use the compound interest formula. This is the compound interest formula that we will apply. And let's solve. We know that the principal is 5,000, so let's solve here. The formula is this. So principal is 5,000. The amount, the total amount that we will have after the growth of the money is 5,618. So 5,618. Okay. Times what? Times 1 plus, and we don't know the rate. Use the formula to find the rate. You don't know the rate. R is going to be the variable, and the time is 2 years. So R here, and time is 2 years. Divide this 5,618 divided by 5,000 equals 1 plus R squared. Okay, and you can apply here the square root property. Remember square root property? Apply on both sides of the equation the square root. This side you can simplify, and this side don't forget to add the positive or negative in front of the square root to apply correctly the square root property. So 1 plus R, and if we don't need the parentheses anymore, we simplify the square root with the square root of with the square, and then we're gonna have 1 plus R equals, and we have here plus or minus square root. We can simplify, actually we can divide both sides, the numerator and denominator by 2, right? And we can simplify. This is going to be 2,500, and on the top you're going to have 2,809. And if you get your calculator, let me get my calculator here. You can find out that the square root of 2,809 is going to be equal to 53, so plus or minus the square root of 2,809, 53, and the square root of 2,500 is 50. This is to finalize. Let me use this space here to finalize, because we will have R equals, then subtract 1 on both sides, subtract 1 on both sides. R equals -1 plus or minus 53 over 50, okay, that will be R equals -1 plus 53 over 50 is 3 over 50, right? And -1 minus 53 over 50 is -103 over 50. We are talking about interest rates, and in this situation, in this particular situation, we had the growth of the money grow, right? So the interest rate needs to be positive to make the money grow. And when we analyze this thing, when we analyze this problem, we will come to the conclusion that the interest rate cannot be negative. So when we interpret the results, we can reject the negative result because we're not going to have, in this situation, a negative interest rate. And we can represent this as a percentage because 3 over 50 is equals to 6 over 100, right? And we can represent this as 6%, with what is usually the way we represent interest rates in this context, in the financial context. So the answer is going to be 6% compounded annually. This is the conclusion of section 8.1. Thank you very much for watching. Next time we work together again. Bye bye.